Hello everyone, welcome to Rapid Gyan. So guys, in this video we are going to solve the examples of exercise 3.2. Exercise 3.2. Okay, so hope all of you have gone through my previous video where I have explained the concept which are needed to solve this exercise examples or even the exercise questions. So those who have not gone through that video, I will strongly recommend guys, please go and watch that video where I've explained the concept, and that concept is very much helpful to solve these examples or the exercise questions. Okay, so you can find the link of that video, link of that whole playlist of this chapter in the description section below. So please go and watch that video first. Try to solve these questions by yourself, and if you are not able to do that, or if you want to cross verify whether your solution is right or not, then please come and watch this video. Okay, so now I'll start with this. That example 4 is saying check whether the pair of equations x plus 3y equal to 6, which is your equation 1, and 2x minus 3y equal to 12, which is your equation 2, is consistent or not. If so, means if it's consistent, then we'll have to find its solution graphically. So guys, if you remember, I have told you what are the criteria to know whether a particular pair of linear equations are consistent or not. So we know that there are three possibilities, like if the pair of linear equations are there, so there are three possibilities. If either they will have the unique solution, either they will have the what unique solution, or second case is they will have infinite number of infinite solution. And what is the third case? Third case means no solution. Third case is no solution. So these two cases are called consistent. If a pair of linear equations falls if it falls under these two cases, then that is called the consistent pair of linear equations. Okay, and if we are getting no solution, means that's inconsistent. Hope it's clear, guys. Okay. Now, how we will know whether they are consistent or not? If you guys remember, I have told you that you will have to compare this linear equation with what? With a1x plus b1y plus c1 is equal to 0, and this with a2x plus b2y plus c2 is equal to 0, and find the value of a1 upon a2, b1 upon b2, and c1 upon c2. So these are the values. Why you need these values? You need this value in order to determine whether the following pair of linear equation is having consistent solution or inconsistent solution. That's why I am recommending you guys to please go and watch the previous video where I have explained this concept. Okay. So what will be the value of a1 upon a2 in this case? The value of a1 upon a2 is, see here, x is a1 is 1, so this is your 1 upon 2. Very simple. Okay. What is the value of b1 upon b2? b1 upon b2 is plus 3 upon minus 3, which is equal to plus 3 upon minus 3, and c1 upon c2 means if both will come this side, so this will become minus 6 upon minus 12, minus 6 upon minus 12, which if I will solve it further, I will get here 1 by 2. Here I will get 1 upon minus 1 upon 1, which is equal to minus 1, and here I will get 1 upon 2. Correct? So if you guys remember, there are three conditions which has been told, that if a1 upon a2 is not equal to b1 upon b2, this is the case of your unique solution. What is the case of infinite solution? The case of infinite solution is that a1 upon a2 is equal to b1 upon b2 is equal to c1 upon c2. This is the case of infinite solution. And what is the third case of no solution? Means this is the third case of no solution is your a1 upon a2 is equal to b1 upon b2 is not equal to c1 upon c2. This is the case of no solution. So it means in this case both the lines are parallel lines. In this case both the lines are, so see, these are the things which you will have to remember. If this is the condition, means both the lines are parallel lines, and if they are parallel lines, they are not going to intersect each other at any point of time. It means that will have no solution. Correct? In this case both the lines will coincide with each other, means like this. one line is this, and another line will be on top of it. So both the lines will coincide with each other. So in this case, the pair of linear equation will have infinite number of solutions. Okay, and in this case it's very simple, both the lines will intersect each other. So this is the case of beta of having unique solution. Means, and what will be that solution? The point of intersection of those two, the two lines, means the coordinates of the point of intersection of these two lines is your solution. Means that's your value of x and y. Okay, beta. So in this case we can clearly see, in this case beta, what we can clearly see, that what is the value of a1 upon a2 and b1 upon b2. We can clearly see this is the case, first case, where a1 upon a2 is not equal to b1 upon b2. Correct? It means this is the consistent. So first thing what we will do, we will show that a1 upon a2 is not equal to b1 upon b2. It means the pair of linear equations is consistent, and if it's consistent and in that consistency it's having unique solution. So now we are going to solve this graphically and find the unique solution. Hope it's clear, guys. So see here beta, I will write x plus 3y equal to 6. I will write it over here, give me a minute. Okay, x plus 3y is equal to 6, and what's the next equation? Next equation is 2x minus 3y is equal to 12. So 2x minus 3y is equal to 12. So how I have told you guys how to find the solution. Means you will have to draw these two lines on the graph paper. So I will start with the first one. Let me find the coordinates. So x, y, so if I am going to put the value of x as 0, so 0 plus 3y equal to 6, so y equal to 6 upon 3, I will get 2, correct? And if I am going to put the value of y 0, I will get the value of x as 6. Okay, so these are the coordinates I got for your equation 1. Now I am going to find the coordinates for equation 2. 2x minus 3y is equal to 12. So what I am going to put? I am going to put some negative value of y. Why I am going to put some negative value of y? Because this will go on the right hand side, this will become positive. And so if I am going to put y is equal to 2, let's put y equal to minus 2. Okay, so here it's x and y, and I am going to put y equal to minus 2. So if y is minus 2, so minus 2 multiplied by minus 3, which is plus 6 will go this side, 12 minus 6, so that will become 6. 2x divided by 6, I will get 3 over here. Okay, guys, if you are having any doubt how I have solved, okay, I will show it over here. But see here what I have done, 2x minus 3 minus 2 equal to 12. So this is 2x plus 6 equal to 12. So 2x will be equal to 12 minus 6. So x will be equal to 6 upon 2, which is equal to 3. So in this way I find the value of x equal to 3. Okay, so I will just rub it because I need space to draw the graph. That's why I am rubbing it. Hope it's clear, guys. Okay, now what I am going to do, I will have to find another coordinate. So one coordinate I have already got. What will be my another coordinate? Another coordinate is, let's put x equal to 0. Let's put x equal to 0. So what will I get? So x will become 0. So y will be 12 upon minus 3. So 12 upon minus 3 is minus 4. So these are the coordinates I got it for the second row. Let's draw the graph. Okay, so guys, if any one of you having any doubt, please feel free to ask your doubts in the comment section. You can send me email, you can WhatsApp me your doubts. I will definitely get back to you. Okay, and you can find my email, my WhatsApp in the description section below. So please send your doubts. Okay, so let me write it over here. I will say this is 1 2 3 4 5 6. Maximum I will have to go till 6. There is no need of going in negative for x coordinates. That's fine. For y its maximum is 2 and minus 4. Okay, so I'll write here 1 2 minus 1 minus 2 minus 3 minus 4. Correct? Now first one is your 0 comma 2. So let's draw 0 comma 2. So this is 0, this is your 2. Correct? So this value is your 0 comma 2. What is the next value? Next value is 6 comma 0. So 1 2 3 4 5 6. This is your 6. I'll write here 6 comma 0. Now what you'll have to do? You will have to draw the line. Correct? So in this way you are going to draw the line. So this particular line is what? This particular line is your what will say the graph, like the graphical representation of x plus 3y plus 6. The graphical representation of beta, I will write over here, x plus 3y is equal to 6. Correct? Now we will have to do the same for this another one. Okay. So next one is 3 comma minus 2. Okay. So x is 3, y is minus 2. So this will be somewhere here. Okay. So this is your 3 comma minus 2. Next one is your 0 comma minus 4. So this point will be your beta 0 comma minus 4. Okay. Now what I will do, I will simply join these two lines. Okay. So I will have to join in such a way that both the lines should intersect each other. So what we are seeing, that both the lines are intersecting each other at point 6 comma 0. Means if I am going to extend this, okay, if I am going to extend this, so this is kind of intersecting each other at a point called 6 comma 0. So this 6 comma 0 is your answer. 6 comma 0 means the value of x, means the value of x is equal to 6 and y is equal to 0. That's your answer. Hope it's clear, guys. Okay. So this is your example 4, and if I will check, you can see over here that your answer is beta 6 comma 0. So in this way we represent it. Alright. So let's go to the next question. Next question is your example 5, showing that graphically find whether the following pair of equation has no solution, unique solution, or infinite many solution. So what are the condition? You will have to find it graphically, correct? Na? So graphically means beta ki the pair of linear equation has no solution means both the lines should be parallel. Just remember this. If it's no solution means both the lines should be parallel. Unique solution means both the lines should intersect each other like this. Not means not this one, means like this. Okay, hold on. Sure, like this. So this is the point. Okay, and for infinite many solution means both the lines should coincide with each other. So what you will have to do? You will have to draw the plot these two lines on the graph paper. That's it. Once you are able to do this, that's your solution. Okay. So let's start with that. So this is your question. So what I'm going to do, I'm going to plot the graph of the first. I'm going to solve this second one and simplify it little bit. Okay. So which will be easy for me to solve it further. So the first equation is already simplified, which is 5x minus 8y plus 1 is equal to 0, and I can clearly see the value of a1 is 5, a2 is minus 8, and c1 is 1. The second one is, since you will have to solve this graphically, otherwise by that equation a1 upon a2 b1 upon b2, that's very simple actually. Okay, so see here beta, 3x. So this is, if I am going to solve this, this is 3x minus 24 upon 5 y plus 3 upon 5 is equal to 0. I am seeing that 5 there is there in the denominator. So what I am going to do, I am going to multiply the whole equation with 5. So here I will get 15x, means what I will do, I will just simply multiply the whole equation by 5. So I will get 15x minus 5 and 5 will be cancelled. This I will get 24y plus 3 is equal to 0. This will be my equation number 2. Okay beta, hope it's clear. Now if I am going to use the, so see, the question you will have to solve it graphically, but I am going to just showcase you how you will be able to solve this with a1 upon a2 and b1 upon b2 and c1 upon c2 concept. Okay, although I will show you with graphically, but that concept I want to show you. So see here beta, let's find a1 upon a2. So what's the value of a1 upon a2 over here? A1 is 5, correct? A2 is 15, which is your 5 upon 15, that is equal to beta 1 upon 3. What is the value of b1 upon b2? So b1 upon b2 is minus 8 upon minus 24, minus 8 upon minus 24, which is again equal to 1 upon 3. And what is the value of c1 upon c2? So c1 upon c2 is your beta 1 upon 3. c1 upon c2 is beta 1 upon 3. So what is the case when both a1 upon a2 is equal to b1 upon b2 is equal to c1 upon c2? When is this is the case when both the lines will coincide with each other. If you guys remember, I have told you, see here, this is the case. This is the case when a1 upon a2 equal to b1 upon b2 is equal to c1 upon c2, means this is the case of infinite solution, and infinite solution means the both the lines will coincide with each other like this, correct? So here we can see beta our this is the case, means this both the lines are going to coincide with each other, but what, how we will have to solve it? We will have to solve it graphically, so we will have to draw the graph, simple. Okay, so let's draw the graph. The first equation is 5x minus 8y plus 1 is equal to 0. I will write it over here. 5x minus 8y plus 1 is equal to 0. Second equation, we got it 15x minus 24y plus 3 is equal to 0. So 15x minus 24y plus 3 is equal to 0. Correct? So let's draw this. So find the coordinates of the first one. I will write over here. This is x, y. I'll just say. Okay. So let me draw it. So if I'm going to, so see, but this we'll have to solve it in such a way that we'll be able to get our answers easily. So see, 5x minus 8y plus 1 is equal to 0. So what I'm going to do, I will write it like this. 5x is equal to 8y plus 1, correct? 8y plus 1. So I will just put any value of y. So first thing I'll put the value of y equal to 0. So y equal to 0, so x will be 1 upon 5, correct? X will be equal to beta 1 upon 5, which is going to give me 0 0.2, correct? So I will write over here 0 0.2, correct? Now I will have to find another value. So another value, how I am going to find it? So I am thinking to put the value of x, the value of x equal to what? We can put x equal to 0 also. Yeah, so put x equal to 0, simple thing. So you will get beta minus 1 upon 8, correct? Minus 1 upon 8. And similarly do the same thing. So guys, see, remember one trick. If you are going to solve this, the same coordinates, if this is the condition, na? If this is the condition of a1 upon a2, b1 upon b2 and c1 upon c2, so in this kind of condition, the coordinates for the second one also, the coordinates for second one also will remain the same. If you want, you can check. See here, if I am going to put the value of x equal to 0, so what I will get from here? So if I am going to put y equal to 0, see, this is the condition, y equal to 0, so what I will get? I will get 15x, correct? Hold on, this is not plus 1, this is minus 1. That's my bad. This is your beta minus 1. So if this is the case of minus 1, my values are going to change. So if I am getting y equal to 0, so in this case the value of x will be minus of 0 0.2. Okay, here also it's same beta, na? If y equal to 0, so what I will get from here? I will get x equal to minus of 3 upon 15, which is going to give me minus of 1 upon 5, which is equal to minus of 0 0.2. See here beta, it's minus of 0 0.2, correct? In the second case, when I'm going to put x equal to 0, so this I will get, this will be plus 1 upon it, correct? So I will get 0 and plus 1 upon it. So this you will get in this case also. So now is simply you will have to draw the graph, correct? So let's draw the graph for the same. Guys, if you are having any doubts, please feel free to ask your doubts in the comment section. Okay, beta? So see here, might be my graph will not be accurate, but if you are going to use the graph paper, you will get the accuracy. Okay. So here I will say, okay, this is since the most of the values are in decimal, so I will just take, okay, this will be going to be your somewhere 1, correct? And this is plus 1, and here it's 0 0.1. I will say, okay, this is 0 0.1, 0 0.2, 0 0.3, 0 0.4, 0 0.5, 6, 7, 8, 9, 10, like this, correct? So x is 0 0.2 and y is 0. X is 0 0.2, sorry, minus of 0 0.2, my bad. So I will take it like this, minus of 0 0.2 and y is 0. So this value I will take. This is your minus of 0 0.2 comma 0. The next one is x is 0 and y equal to 1 upon 8. X is 0 and the value of y is 1 upon 8. 1 upon 8 is means around 12.0.125, correct? 0.125. So if this is 0.1, this is your 0.2. I will say this is 0.1, this is 0.2. So the half one will be 0.15 and half of this will be 0.125, correct? So this is that point 0.125. So now what you will have to do? You will have to draw that line. So simple. So this is the equation. And of course the second one is having the same coordinates. So second one is also going to give me the same line. The second one is also going to give me the same line like this. Check here. So means, so this is the case, hold on, this is the case. So this is your line 1, okay, I will say this is your line 1 and another one is your line 2, this is your line 2. Hope it's clear, guys. So in this way we can say that our particular these two equations are going to have infinite number of solutions. See here beta, are having infinite many solutions. Hope it's clear, guys. Okay, now coming to the example 6, I have already written over here, so let's go and solve it. So what the example 6 is saying, Champa went to a sale to purchase some pants and skirts. When her friend asked how many of each she had bought, she answered that the number of skirts is 2 less than the twice the number of pants purchased, and also the number of skirts is 4 less than the 4 times the number of pants purchased. Means, guys, see, we are solving pair of linear equations of two variable. Means we will have to draw, we will have to find out two equations from this statement, this question, and both the equations should be of two variables. So what we are going to assume in this case, so we are going to assume, like, suppose she has number of pants purchased by Champa. Let's assume number of pants purchased by Champa is equal to x and number of skirts purchased by Champa is equal to y, correct? Now what is the first condition given? The first condition given is that the number of skirts is 2 less than the twice the number of pants. Means twice the number of pants means 2 times x, number of skirt is 2 less than minus 2 means 2x minus 2 is equal to y. So this is your equation 1. Hope it's clear, guys. See, it's saying na, that the twice the number of pants, so 2x is the twice the number of pants, 2 less than minus 2 is equal to your number of skirts. This is your equation number 1. What will your next equation beta? Next equation is saying that the number of skirts is 4 less than the 4 times the number of pants purchased. Means 4x minus 4, 4x minus 4 is equal to, correct na, 4 less than the 4 times the number of pants purchased. 4x minus 4 is equal to, is what? Is equal to your, again, y. This is your equation 2. Okay. Now we will have to solve this equation. So how? So your first equation is 2x minus 2 is equal to y. So let's simplify it. So this will become 2x minus y minus 2 is equal to 0. This is your equation 1. Second one is your become 4x minus y minus 4 is equal to 0. This is your equation 2. And now you will have to find the value of x and y. So in order to find the value of x and y, what you will have to do? You will have to solve these two equations. And we only know the graphical method of solution. So how we are going to solve this? We are going to draw this on the graph paper, correct? So before going and drawing the graph paper, first we will see that whether this exists a unique solution or not. So what is the value of a1 upon a2? So a1 upon a2 is 2 upon 4, which is equal to 1 upon 2. What is the value of b1 upon b2? So b1 upon b2 is your minus 1 upon minus 1, which is equal to 1. So of course the first condition I can see that a1 upon a2 is not equal to b1 upon b2. It means this is going, these two lines are going to intersect each other and they are going to have the unique solution, correct? They are going to have a unique solution. So now I will going to draw the graph. So it's 2x minus y minus 2 is equal to 0. I will write over here 2x minus y minus 2 is equal to 0. This is your equation 1. Next equation is your 4x minus y minus 4 is equal to 0. This is your equation 2. I'm going to find the coordinate of the first equation. So first equation I will write over here x, y. If x will become 0, y will be beta minus y minus 2 is equal to 0. So the value of y I will get, this will become plus 2. So y will be minus 2. Correct? And if I am going to put y equal to 0, so y will be 0. So what will the value of my x? X will be, this will become positive and x will be 1. So this is the one set I got. Now the next one, for this one, x, y, let's solve this. Here also put x equal to 0. So if I am going to put x equal to 0, this is minus y minus 4 means y is equal to minus 4. Very simple. If I am going to put y equal to 0, x will be beta, this is minus 4 will go that side, 4 upon 4, that is 1. Okay, so see from here I can got the answer 1 and 0 where it's going to intersect. But anyway, we will have to showcase this while drawing the graph. So this is the graph paper which I'm going to draw, and I will go with the first, hold on. So this is your 0, I'll say 1, 2, 3, 4. 1, 2, 3, 4, 1, 2, 3, 4. 1, 2, 3, 4. First one is 0 comma minus 2. So x is 0, y is minus 2. So this is the point 0 comma minus 2. I will write it over here, 0 comma minus 2. Next point is 1 comma 0. So this is the point beta 1. I will write here 1 comma 0. Okay, so let's draw that line. I will draw a line from here to here. Okay, so this is the equation of 2x minus y minus 2. This line is representing 2x minus y minus 2. Now find for the 4x minus y minus 4. Let me change the color. So this will be beta 0 comma minus 4. So this will be your 0 comma minus 4. I will write here 0 comma minus 4. And next one again 1 comma 0. So this will remain the same, this point. Okay, and you will have to draw the line. So this third one is the 4x minus y minus 4 is equal to 0. So what is the point of intersection? Point of intersection is your 1 comma 0. So that's your answer. Okay. Now how will you verify that whether your answer 1 comma 0 is correct? Whether your answer 1 comma 0 is correct. So in order to verify this, what we do, we simply put this in the equation. So your first equation is beta, see here, 2x minus y minus 2 is equal to 0. If I am going to replace the value of x and y with 1 and 0, means x with 1 and y 0, so this equation should satisfy, means LHS should be equal to RHS. So the value of whole equation is 0. It means if I am going to replace the value of x with 1 and y with 0, my answer should be 0, correct? So let's check. So 2 multiplied by 1 minus 0 minus of 2. So if I am going to solve, so this is 2 minus 2 which is equal to 0. So I can see LHS equal to RHS. So first equation satisfied. Now the same should satisfy the second equation. So now put it. So this will be a 4 multiplied by 1 minus of y which is 0 minus of 4. Solve it. So 4 minus 4 which is equal to 0. So here also it's satisfying LHS equal to RHS. It means your answer is correct. So how we are going to verify the answer? Simply by putting the value of, by replacing the value of x and y in both the equation, and if both the equations are clearly satisfying, means by just validating by whether LHS is equal to RHS, it means your answer is correct. Hope it's clear, guys. If any one of you are having any doubts, please feel free to ask your doubts in the comment section. And that's it from this video. In the next video, I will start with exercise 3.2. Okay, bye bye, take care.